Hi, and welcome to Calculus Examples. Today we are going to look at the limit of this function right here. And you notice we have a trig function on top and we have a square root of x on the bottom of our fraction here. When we have a limit and we're looking for something with a sign of x in there, the key is that we want to think automatically about our squeeze theorem if we can. So remember, the squeeze theorem says if we have a function that's stuck between two particular values, in this case, sine of x, as we know, looks kind of like this, right? It goes up and down and up and down and keeps on going. And it never gets bigger than +1, and it never gets smaller than -1. So it's bounded by those two things. If we can modify that and show that to look like the function that we have here, and show that the boundaries, the outer bits, so that would be whatever we end up on these two sides, go to the same number, the stuff in the middle has to go to the same number. Now you'll notice I started off with sine of x is between -1 and 1. That we know for sure. But our function here is sine of e to the x plus x. The key to remember here is that sine of e to the x plus x, it really doesn't matter that we have all this junk in here because sine of whatever you're plugging in is still bounded by -1 and +1. So it's not going to change our boundaries in our squeeze theorem, which is great. Now we do want it to get looking like the function that we see in green. So we are going to divide each side of our inequality by square root of x. So now we have square root of x on everything here. We know that as x goes to infinity, 1 over the square root of x, that is going to go to the number 0. So we'll -1 over square root of x. Because remember what's going on here is this number in the denominator is going to get huge. The fact that we are taking the square root of it is not going to make a difference. Our x is still getting big enough that this is going to grow. And when you take 1 over a really huge number, the result as a total is a small number, and that small number is going to get smaller and smaller until we get to 0. So that means that the function that we are looking for goes to 0 as well. When you do a problem like this, don't forget to use the words by squeeze theorem in your solution so that your teacher knows that you know where this is coming from. A lot of teachers will take some points off if they don't see the actual words squeeze theorem. I would ask your teacher what they prefer just so that you know in the end. All right, there we go. Thank you for listening.